Hello, everyone. Today I'm going to share my classroom. I have some course building recommender system with machine learning and AI. Click here and now share the course and click in this.
At this point, you're probably getting a little impatient to start delving into actual recommender algorithms, so I'm not going to spend a ton of time dissecting the code of our recommender system framework, but let's do a quick tour. Start by launching Spyder from your REXIS environment, and open up all of the files inside the framework folder inside the course materials. Let's work backwards and start from our script that actually uses and tests out this framework. That would be the rexbakeoff.py file. We start by importing the modules we need. Notably, all we need are the recommender algorithms themselves that we want to play with, our MovieLens module that loads our training data, and the Evaluator class we talked about. So the only part of our framework that we really need to understand is the Evaluator module. It hides the complexity of the other modules from us, so we don't have to worry about how our evaluated algorithm or evaluation data modules work. The code here is pretty simple, although there are a few finer points that we didn't mention in the overview. First, we have our load MovieLens data function, which does what it says. It uses our MovieLens module to load up a surprise-lib dataset containing our movie ratings data that we'll use for training and testing each algorithm, and it also gives us back a dictionary of the popularity rankings of each movie. We need those rankings in order to compute novelty. We've seen the MovieLens module before, but if you want to study its inner workings again, feel free to go through its code again. Data processing is often half the battle with recommender systems and machine learning in general. We set some random seed values, which just ensures that we get the same results every time. Then we load up our data here. Now we just create an evaluator object using the MovieLens data we just loaded up. We create an SVD recommender algorithm and a random recommender algorithm as sort of a baseline, add them both into the evaluator, and then call evaluate on it. Really simple, right? That's the whole point. We want to make it easy to evaluate new algorithms so that in the rest of this course, we can just focus on the algorithms themselves. So let's dive into the Evaluator module that we're using here. Open up evaluator.py to see what it does. You can see that internally it maintains a list of algorithms. These are actually evaluated algorithms, as we'll see. When we initialize an evaluator, the first thing it does is take the raw dataset and popularity rankings you feed it and convert it into an evaluation data object instead. This takes that raw data and makes all the different train test splits we need to evaluate it with. This gets stored as self.dataset. In Python, when you want to use a variable associated with a class instance, you always refer to it with self. Next, we have add algorithm, which just takes a raw surprise-lib algorithm and converts it into an evaluated algorithm, then adds that to the list of algorithms we want to evaluate later on. And that's what evaluate does. It just calls evaluate on each evaluated algorithm that you gave it and tabulates the results and prints them out nicely. Notice the doTopN parameter. This allows us to bypass the computation of hit rank metrics if we want to, because they can be very computationally expensive to produce. When it's done, it just prints out a nice little legend reminding you what all those different metrics really mean. One more thing. We also have this sample topN rex function here. Sometimes it's helpful to look at the actual recommendations being produced for a known user whose taste you understand at a more intuitive level. It can be a helpful sanity check. So this takes in a MovieLens dataset so we can convert movie IDs into titles that actually mean something to you, a user ID that you want to get recommendations for, and how many recommendations you want to get.
Okay, let's go stop this video on this place. And in this occasion,
So
continue
for
with
each
other.
recommender algorithm, let's look at what's going on.